Hello guys, welcome back. So today we'll be trying to reproduce this, which is the Boids simulation, flocking, whatever you want to call it. So yeah, let's get into it. So, all right, let me reset everything. The only thing I'll be keeping will be the quad tree, right? So we will be using the quad tree from a previous video, which I'll be linking down in the description below. If you want to follow along, you'll need the quad tree example first. All right, so the Boyd's principle. Let me pull up the Wikipedia page over here. Awesome. So, uh, the Boids are basically just a simulation of flocking entities, right? So, group following entities. And it's based on three pretty simple rules. So, each Boids, each elements, each uh, autonomous thing will need to know its awareness, right? So, any other entities surrounding it, and will need to adjust its steering based on the other ones around it, right? So it'll need to adjust based on the separation. So giving distance, like trying to get away from the other ones, trying to align in the same alignment as the other one, and cohesion, trying to be at the center of the other ones, basically. So that's the whole goal of today, right? And afterwards we can make it bounce whenever there's a wall or something, right? Make it avoid the walls, maybe. And so yeah, so that's pretty much it. So we'll get started on this, right? So this is the example running right now. Yeah, so that's pretty much it. So let's get started. So we'll start with the class Boyd, right? So these will be our entities that we will have. You'll need for sure so it's pretty much like any other thing that will move. So we'll need a position, right? We'll need also a velocity. We will also need the acceleration value. Let's start with this, right? So let's say whenever we first create the Boyd, let's say we do pass it the XY, so the position, the initial position, right? So let's start with that. Awesome. So pos equal new p vector with XY, velocity equals new p vector, and we might want to set like a random initial velocity to the Boids, just so that they're not still at the beginning, because they might not be close enough to act on each other's from the start, right? So we might not want to set the velocity as 0. So we'll see. And then the acceleration should be just 0 to begin with. Awesome. Okay, so let's do the most complicated part first, right? So we'll have a function called, let's say, called steer, right? And this should receive like a list of Boids, right? So a list of Boids, right? Okay, call it Boids. Okay, so let's set a radius which we want to query, right? So let me get to whiteboard. Okay, awesome. Okay. Where's my marker? There it is. Okay. So we will have initially, like, let's say we have a couple of Boids, right? So those points are just all Boids. It's a bit difficult to see, but there are points over here, right? So we will want, let's say this one right over here, to modify its trajectory, its velocity based on the other Boids around it, right? But let's say we have Boids around here as well. We don't want it to adjust itself based on all of the Boids, but only a specific like section around him of Boids. So we'll be doing like, let's say a circle. So we'll be taking the Boids in here, right? All of those Boids would be the ones that are changing this one's trajectory, right? So we will need to get the like radius from which the Boids, the other Boids matters, right? So let's get a float in here. Call it, I don't know, radius. I don't know. I'm not great with names, but radius distance. Let's say we want 50 as the distance of which we do take into account the Boids, right? So we will have to do something like, so for each Boids in Boids, so for each Boid in Boids, we first need to check if it's the same Boid as the current one we just discarded, right? So if Boid is equal to this, we can just continue skipping this one as it's the same one as we're currently on. Okay, else well, the other if, right, the other condition. So well, let's get a float distance over here. Distance equals, and we'll use the distance function from p5, just getting the square root of the distance between x and y squared, right? All right, so we'll need the position of the current one, the current one, yeah, and the position of the other Boid, right? Okay, awesome. And so we need to check if that distance, if the distance is greater than the distance that we set, then we'll just continue as well. It shouldn't affect it. Okay, otherwise, now, this is where we need to figure out what to, let's say we have, so we will have, like, we will need three forces, right? We'll need a force for separation, alignment, and cohesion, right? For each of the Boids, but we'll do an average of the ones surrounding it, right? So we'll do a p vector for each of those. Alignment, well, new p vector. Awesome. So we'll copy this. We'll do separation and cohesion. Okay, awesome. So it should be pretty straightforward for both, I believe, for both the alignment and cohesion, if I remember properly. I mean, anyway, we'll be doing it on the whiteboard first. So, right. Well, the first one that is pretty easy should be alignment, right? So the alignment should just be adding the vector, the velocity of the other Boid, right? So alignment.add, and we can do Boid.velocity. Awesome. Okay, so that should be pretty straightforward for the alignment. And then afterwards, we want the average, basically. So we'll do alignment dot divide, and we'll divide by the amount that we added, right? So we'll need to get that amount some way, right? So let's call it amount 0 starting, and let's do amount plus if we get to here. Okay, and we'll divide by the amount. Okay, all right. So we've got that. Now, right, okay, what's the issue here? Invalid character. There's always an invalid. I really need to fix this. Oh, there we go. Okay, it's always a space. Okay, so the cohesion should be also pretty straightforward, but instead of the velocity, it'll just be the position, right? So Boid, because we want to average the position of all the other Boids, so it should just be the position. So pause, right? Okay, let's go back into Boids, okay. And then the last one, which is, well, it's the second one on there, but doesn't matter. What's the issue here? Global variable x does not exist. Global variable x? There's no global variable x I'm trying to use here. I don't know. Anyway, we'll take a look at the error afterwards. So, separation. So what do we need to add in here, right? So we want to separate the voids, right? So we need to subtract. So we need to. So let's take one of them, right? And then we will need to average it. So we'll do the sum of it, of the sum of the subtraction we need to do, and then we'll also need to subtract our specific position, right? I think. Let's see. So, no, it's really not big enough. Anyway, so it should be something like p vector. We want to subtract from this void the position, right? We want to separate ourselves from the position, the global position of the ones around us. So the position of this one and the other void, right? Okay. I think that's it. We might want to do something about the distance, right? Because the distance might affect, right? So if it's further away, the distance should, well, here, right? If, well, they're pretty much all at the same distance, but let's take this one, right? This one is closer to the current one than this one, right? So we might want to adjust what we subtract based, like we might want to subtract more if we're closer to ourselves, right? Yeah, possibly. If I do mode distance, then that would be the opposite of what I want, right? But let's try it. Who cares? What's the issue over here? Distance, pos.x, pos.y, boid.x, boid.y. Global x is not defined. Where? What global x? Let me paste that somewhere else and paste it back. Maybe it's distance, it's a reserved keyword, who knows? That's not the issue. Maybe this. No, that's, oh, you know what? Yeah, I'm just, I don't know. I might be a bit tired. That's probably why. There you go. Awesome. Okay. Okay, great. Yeah, this might not be right. We might want to modify this multiplicator, but we'll see. Yeah, we'll see. Okay, so the alignment, we want to subtract the average. To the average, we want to subtract our own, the alignment, the velocity, right? So velocity. And we want to also multiply by a given value, any kind of constant, right? So we'll do float. alignment force, maybe alignment, maybe 0.01, 0.3, I don't know. Let's go with that. So we'll have tree force, cohesion, alignment, and separation. Okay. Let's do maybe a lower cohesion, maybe like 0.03 as well, and let's do separation force a bit bigger. Okay, let's go with that, sure. So alignment, then cohesion. So the cohesion, do we need to do something specific for it? Yeah, well, we definitely need to divide it by the amount, for sure, since we want the average. And do we need to subtract our own position? No, I think that's fine. And then mult by the cohesion force. Okay, great. And then the separation, divide by the amount. And we will need to subtract the position, right? I think. We'll see. Sure. Okay. So now we need to add those three to the acceleration, right? So we can do a function for that. Apply force, and we'll receive a p vector as force. We'll just do add to the acceleration the force, and we'll have an update function as well, which will just update the position based on velocity, velocity based on acceleration, so on and so forth, right? So velocity, add the acceleration, and we might want to set like a magnitude, like a constant magnitude, like a constant speed if you want, to the velocity, but for right now let's leave it at that. It might be a bit slow, but we'll see what we do. And then to the position we want to add the velocity. Awesome. And we will also want to reset the acceleration. We can mult by 0. That should do it. Okay, I think this is right, but we'll see. So we need to call apply force for all of those. Let me remove this, save. Okay, yeah, that's okay. I think that's right. Let's also create a function for the edges. So for right now, we won't do it that it gets repelled by the edges. We'll just do like if it's over the edge, it just gets pops out on the other side, right? So if pos.x is smaller than 0, pos.x is now the width, and then we'll do else if pos.x is greater than the width, then pos.x should be equal to 0. We'll do the same, but for x. For y, yeah, my bad. Y will be the height, y, height, y. There we go. Okay, I think we're pretty good with that. Let's do a show function. So void show, where we'll just show a point currently right now. So stroke 255, let's say. Stroke weight, maybe 5 for right now, maybe 10 even. Let's do 10. We can change it afterwards. And let's do a point at pos.x and pos.y. Okay, all right. So over here. So we'll have an array of Boids, right? So let's get an amount of Boids as well. So let's do int amount, well, amount of Boids, or the flock size, right? Let's do 30 for right now. Let's do a pretty small amount. Let's do our array of voids. We'll call it flock equal to new voids array of flock size. Okay. Boid is not defined. Class Boid. Let's see. Let's do void setup now. Okay, it resolved the issue. So awesome. And void draw. Okay, so we'll do a small size for right now, maybe 600 by 800, and we will fill in our flock. Okay, so for the amount of voids that we will have eventually, we'll do flock index I equals to a new void starting at a random value between 0 and width. So the position will be random to begin with, and random between 0 and the height. Okay, all right. And let's just draw them, not updating them. Let's just draw them. So let's do a background. Well, pretty dark background. And let's do for each void in flock, sorry. Yeah. Let's do void dot show. All right, let's see this. Okay, good. So we have points. Nice. Let's try without the quadtree. We'll add the quadtree whenever we get it working first. Let's get it working. Let me also move all of the variables that we have here over to the main file, just so that it's easier to play with. Okay. Still all good. Okay, awesome. So let's do void dot steer, and we will steer with the flock, and let's do void dot update. Let's see just this. Okay, well, probably too fast. It moved too fast. There's probably an issue, but it probably just moved too fast for us to see. So let's do void dot edge. Did I call it edge or edges? I think it's edge. Anyway. Okay. So what's the issue? Let's try maybe limiting the velocity to 1. Okay, still not getting what we want. Okay, so multiply by the alignment force. We need to subtract from all of it the velocity. Well, I'm not sure I do. Actually, let me think about this. Boids position, subtract. Why is it not showing? Let's try console logging positive x positive y. Well, not console logging, printing out to the console. Yeah, I'm still in JavaScript mindset. All right, not a number. Okay, good to know, good to know. You know what? We cannot divide by the amount if the amount is 0, right? So we'll just say if the amount is 0, then let's just return early return. What's the issue? Oh, yeah, I get it. Okay, awesome. Does seem to be doing something. Let me remove also what we thought could fix the problem. Let me remove this. Let me remove the print as well. Okay, let's see it. Way too fast. Totally way too fast. Okay, so I don't know why there's one single one alone there. Might just be a fluke. Well, it's not really a fluke. Let's try setting the max. Well, let's try setting a fixed speed. So set magnitude to maybe like 3, just for right now. Okay, so does it seem to work? It seems like it does. I would say maybe the separation force is way too big. Oh yeah, you know what? Let's try setting an initial velocity to all of this, right? So let's do random 2D vector. And let's set a random magnitude, which would go between, let's say, 0 and 4. I think this seems... Cohesion might not be big enough. I really want them to try to clog up together, right? So let me go back to here, right? Cohesion. Divide by the amount, multiply by the force. Do I really need to sub the velocity on this one? I don't think so. Okay, maybe also setting the radius to something bigger, maybe? Maybe 100 is a bit much. Let's try to add a lot more of those, right? Maybe 100. They seem to be trying to go in the same direction. That's good. Maybe 0.9 over here, right? Seems like they're always trying to go, well, for you it would be in this direction, right? So it's always trying to go there. Possibly subtracting the velocity was right. And we might need to also do it to the other one. Doing, possibly doing it beforehand? I'm not sure anymore. um, Let me look at what I did previously. No, that's not right. Yeah, that was right. Okay, right. Yeah, seems to make sense. Okay. Okay, let us try on a bigger canvas. Maybe we're just not seeing the big visual, right? I see. That seemed to clog up everything together. Sure. Well, it's doing something. I'm not sure if it's what I expected it to do. Let me take one last look at what I did. Right. Okay, I think I get it right now. Remember this multiply distance? I think we should do the inverse of this, which is dividing. Okay, that seems correct. Okay, we were there pretty much. Okay, let's now put back something that makes a bit more sense. So separation needs to be pretty high, I guess. We don't want them on top of each other, right? The cohesion seems way too big right now. So cohesion maybe 0.3 as well. Maybe do the radius as, yeah, 7.5 seems good. Okay, that seems fine, right? Though they're all clogging up on the same one, right? Let's do a much bigger separation, maybe 0.5. And I'm not sure subtracting the velocity was such a good idea over here, since it wasn't that the issue, right? Because we're not even like using our own velocity, so it shouldn't do anything. Okay, separation force, definitely not high enough. And cohesion force, definitely too high. Also, let's try changing the alignment, maybe a little bit less as well. There's something weird. When they get into the line, yeah, cohesion, let's do even less. Okay, and I don't like that random 2D vector stuff. It might not be exactly what I expect it to be. Let's try instead this, let's do from angle, where we get a random angle between 0 and 2 pi. Why are they all going towards the top left, right? There's an issue over there. Do we actually need to sub the position? That might have been hit, right? Let me try moving. Whoa, where's my mouse? Okay, there it is. Let me try adding back the cohesion, maybe putting this down a little bit and maybe this up a little bit. What's the issue? Error on Boids. What? oh yeah, I'm missing my column. That seems better. Let me try upping the speed, right? Let me do 10. And this seems kind of right. Okay, let's go with that. I guess. Sure. Why not? Let's go with that. Let's do a constant as well for the speed. So Boid speed equals, let's say 5 right now. 10 might be a bit fast. Well, we'll see. Boid speed. Do we have anything else we want as a constant? Not for the current time. Okay, now let me use the quad tree. So I will be modifying it a little bit. So instead of this, we'll get void. And well, we don't need to state it here. This will be void. Okay. That's fine. That's fine. This will be void. Will be void over here as well. It won't be .x. It'll be .pos.x. .pos.y. Anywhere else we have an issue, we'll just run the sketch. There you go. Void run. Okay, point. Well, yeah, sure. Dot pos dot x. Point dot pos dot y. Try again. Okay, works. Okay, so over here, if we want the quad tree, we can just do quad tree. Let's call it tree equals new. Well, let's do the new quad tree in here. So new, well, tree is equal to new quad tree. What do we need to pass it? I don't remember. It was boundary and capacity. All right. So we'll do a capacity of maybe 5. That should be enough. And the boundary, let's just create, let's just do the boundary right there. So new, the boundary will be like the screen. So the initial quad tree, let's say. Which will be starting at 0, 0. It'll be of width, width, and of height, height. Okay, awesome. Still no issue. Okay, great. So in here, we'll need to do, well, in here, we'll be doing, right, so we need to insert into the quad tree, and then we need to query the quad tree, right? So what's the insert function look like? I don't remember. Insert void. Inserting one at a time. Okay. Not sure that is the most efficient, but we'll do it like that for right now. It doesn't matter. It'll be efficient enough. So tree dot insert the void, and over here we'll do a range that will be the query range, right? Will be equal to, and I want, so this will be, the range will be based on the middle. So let the new range, first thing first, xy should be void.x minus half the search radius. In our case, let's do this, but call it diameter. So it'll be this. Whoa. It'll be this divided by times 2. Times 2. Okay, awesome. So we'll need x minus this Yeah, right. Right. Let me try something up. Oh, and this is not right. It needs to be pause dot y minus this, and then it should be no errors. Let's do range. So let's go do tree.query range. Oh, and we need to set the Boids. So a new array list of Boid. Call it B because Boid's already used. So let's call it B. That's fine. A new array list. Awesome. I think it's like this, right? Query. Yep. Okay. Let me go back here, and we will pass, instead of the flock, we'll pass B. We'll need to change steer to get an array list instead. Still working. Awesome. Okay. Let's try to show them not as point, but as triangles, right? So let's do push matrix because we'll be using translate and rotate. So I'll be using push matrix. Push matrix and pop matrix, both of those. Okay, great. And we'll do a triangle at, let's say, 0, 0, going, let's do a triangle pointing, well, like this to begin with. So 0, 0 will be to this side, and then we'll have the two other points over there. So it'll be minus 10 for the x, minus 5 for the y, minus 10 for the x, and 5 for the y. That should do a triangle. We'll do translate to pause.x, pause.y, and let's do rotate based on the velocity heading, which is just the angle of the vector. Okay, let's see this. Okay, I think it's right. See, it's moving that direction. This one, okay, yeah, it seems right. I think. Yeah, I mean, sure. Separation force could be a lot bigger. Let's do separation. Well, a lot bigger, maybe a little bit bigger. Sure. Okay, let's do a little bit smaller, maybe 5, 5, 5. Let's do an equilateral triangle. No, they won't be. Let's do 7. Sure. Let's do 3. Okay, that's fine. Let's do the cohesion might be too strong, to be honest. Might not be the separation the issue. Cohesion, let's do like 0.2. Why are they also all coming from here? Oh, it's because they're going in the right line. Anyway, let's try now to do avoiding the walls, right? So let's create a function called avoid. So we will want to avoid, we will basically will want to repel the x, the position x, but whenever the Boid is at a certain x distance from the wall, right? So horizontally close to the wall, will basically create a vector pointing in the direction opposite to the wall. And adding that to the velocity of the Boid. Sure, let's do that. So we'll need, whoa, where are we? Okay, here. Okay, so for the left wall, let's start with the left wall, right? So let's do float distance left, right? So the distance from the left wall, which should just be pos.x, right? If you think about it, 0 plus whatever distance. So let's call it dist left, right? Sure. So if dist left is smaller than, I don't know, maybe 75, right? Sure. Let's do apply force, and we'll need to create a force. So we'll need a vector pointing in the, right, in that direction. So, which is just the angle 0, right? If you were to take it from an angle. So we can use p vector dot from angle, pass it the 0 at the angle, do dot, and then we can multiply even by the actual distance that we're, right? Because if we're closer to the wall, let's say we want to repel a lot more, right? So let's say like 75 minus dist left, right? This should, if we try this, we should not see Boids going close to the left walls. Let me do it before the steer. Boid dot avoid, I think I called it. Let's see. So they're not going toward the left wall. I mean, there's none that are trying right now, but they did try and they never succeeded, right? Okay, let's do the top wall now. So top should just be based on the y this time. This top. Same thing, but this time we want it to go down, so it should be half pi. Think. Okay, the right one, it should be width minus pos. Right. The angle should be pi. Right. And the bottom one should just be the height minus the y value. And the value should be pi plus half pi, right? I think so. I mean, we'll see. Okay, let's see it. Okay, so there's definitely an issue where they're all adding to their velocity some small positive vector, right? So where is that coming from? Actually, we might really need to subtract the current velocity, right? Okay, not only on the alignment, possibly also on the other ones, right? Not sure why. There still seem, okay, since this one is using the position, let's also try to subtract the position. No. Now they are all going in the other direction since we subtracted the position. That makes sense, but it's not working. This is still trying to go to the bottom right. Why is that? Could it be that this is inverted and it needs to be the other way around? Doesn't seem like it. Let me check what I did previously. So that makes sense. Okay. Sure. I mean, subtract velocity. What exactly is the issue here? So alignment, we're adding the velocity. That's right. Cohesion, we're adding the position. That's right. Separation. We're creating a vector from the subtraction of this position and the other Boids position. Sure, and we're dividing by the distance before adding it to the separation value. Then we divide all of those by the amount of Boids we added. We subtract them all by the Boids velocity. Fine, that's what we did. Sure. And the one for the separation, we subtract on top of that. I mean, that's what I did previously. I subtracted the position of the current one. I'm just wondering, that doesn't make sense much to me. Right? I mean, they're all going on the other side. Seems like for some reason they're always trying to get to somewhere that does not exist. Where am I doing something else that could be doing that? I mean, the distance, we're not modifying anything here. And the position, sure. Divide by the amount, makes sense. Multiply by the alignment, subtract the velocity, subtract the position. Let's try and play with our values here, right? Let's try all of the same value. See what does that give us. Okay, this actually seems better already. Could it have just been that? Possibly. It might be the separation. I no clue. Let's try separating them a little bit more. Okay, separation is really doing something wrong. Like, actually. I mean, I'm doing the same thing as before. Let me get back to you on this. All right, so I figured that out. It's one of the dumbest problem I ever did. So it's the cohesion that needs the subtraction of the Boids position, not the separation force. So over here instead of over here. All right, so doing that gives us something like this, right? And okay, fine. And we can maybe make the triangle a lot smaller, maybe 5 here, maybe 1.5 here, 5 here, 1.5. And they're still big. Let's do 4, 3, let's do 1, 3. They're like glitching out of existence. It's pretty weird. I think I liked them more as points. Let's just do points. At pos.x and pos.y. Let's do wait, stroke 255 and stroke weight say 10 since they're just points. Sure. That's looking good. Let's add a lot more of those. Maybe right now I currently have 100. Let's do 250. So you can see them bounce off the edges. Let's maybe change also the speed to 10. I mean, currently the slowdowns are happening whenever they're querying, right? Because they're so bunched up together that they need to check a lot of them. So we might want to do something like radius distance. Might want to add a little bit to the separation force. Not the cohesion. Separation force. Maybe like this. Yeah, that's a little bit better. Right, so I mean, it's not running pretty fast. You could probably optimize this a lot. I mean, I'm sure you can. Though it doesn't matter, I did what I wanted to do. One last thing we can do is instead of searching the Boids, the closed Boids in a just a circle pattern, right, based on a radius, we could try looking at if they're in an arc, right? So we can try this. So this is the Stack Overflow I found. If we take a look at here, the formula is just getting the angle. So basically, get the start and end the angle that you want to look at, right? So if it's where, depending on Boid's velocity, right, wherever the Boid is pointing, however much you want to look at. So let's do a constant for like the angle that we want to look at. So maybe float arc angle. I don't know. Let's do that. So arc angle, let's do half a pi. So in total, we'll be looking at half a circle, basically. Like we'll be each Boid will be seeing the other Boid's half circle in front of them, if that makes sense. Anyway, okay, all right. So in the Boids, let's first remove the edges function. We don't need it anymore. There you go. So what's the issue now? Invalid character. Again, I really need to fix this eventually. There, it's always just space. Okay. So it would be over here, right? So we know the distance. Okay, so it's for sure after we're checking the radius, right? If it's not in the radius, it doesn't matter if it's in the viewpoint. So okay, so we'll calculate S and E, which should be start and end angle. Okay, so start angle. So float S should be, so we can do float heading, which will be the angle of the Boid currently. So it should be the velocity heading. Okay. So, and now we just want heading start minus, what did we call this? Arc angle. Or vision angle, whatever you want to call it. Float E should be same thing, but plus arc angle. Okay, so we have our start and end angle, and now we need this angle, this A value. I'll just copy it. And the center X and center Y in this case would be our Boid position. And the X and the other X and Y would be the other Boid we're checking against. So let's get this over here. Let's comment it out. Okay, great. And we'll do float A is equal to A10 2. I'm not sure the math behind it, but it's just trigonometry after all. So y, so it would be Boid dot y minus pos. Well, Boid dot pos dot y minus pos dot y, and then Boid dot pos dot x minus pos dot x. And then we just need to make sure, so let's do the inverse, and we'll just continue if it's not what we expect. Okay, so in here, we need to check. Basically, I think it's somewhere, where was it? Okay, anyway, if it's valid if A is between S and E, basically. So if S is smaller than A, and if A is smaller than N, right? If it's not this, we just go to the next one. Okay, what's the issue? Invalid character again. That's really frustrating. Let me copy this somewhere else. Paste it back. Whoa. Okay, anyway, there you go. So now it should just be looking in front of itself. It's looking really cool, I have to say. There's really some kind of slowdown happening at some point in time. I'm not sure exactly why. It might be the memory management, like the garbage collector, the GC having some trouble with it. That's most probably what's happening. I might have some stuff that is getting done that shouldn't be, or I'm not doing, which I should. I don't know. Oh, you know what? I think I should create a new quadtree every time. Right? Yes, there you go. That's much more fluid. Let's up this to maybe 250. Let's see it. Okay, let's maybe slow down a little bit. I think I was putting it higher than it was supposed to be just because it was running slow, but there you go. Okay, let's see it. If it looks good, I think we're good. Looks pretty convincing. I know you're not able to see the top of the canvas, but it's the same as the bottom, basically. So it's bouncing around, right? So this is looking good. One thing you might want to do, maybe show the half circle, right? In this case, we could just set the start and end angle so that like we could just recalculate these two in here. But yeah, let's just do that. It's fine by me. So let's copy this, put it over here. Okay. Let's do these two over here. Let's do stroke weight 1, maybe 2. Let's do an arc that goes from the center, which is pos.x, pos.y, with a radius of this. Well, in both the width and height, it might be double. Yeah, it might be the diameter that it needs. Yeah, I think it's width and height of the ellipse, which of the arc, sorry, and then the start and end angle. And we want a pi, right? And we want no fill. What's the issue? Missing semicolon, for sure. There we go. It's not. All right, so my microphone did not have any battery left, but what you see here is just what I ended up with. I was already doing the show function, updating the show function, but this is just the final show function. So showing the arc with some purple value, purple color, and then showing the velocity arrow kind of as a red line. So that's pretty much the sketch. Hopefully you liked it. It was entertaining for you. Leave me in the comments some suggestion for next sketch that you want to see, and share with me whatever you do with this sketch. Hopefully it is creative. For sure it will definitely be more creative than mine. Well, thank you for watching. Hope you liked it, and see you next one.